Alright, so here's a video about section 2.7. Okay, so we've talked about secant lines a little bit before, but let me start by defining it again. A secant line to a graph y equals f of x is really just a line between 2 points. You have to be given information about what 2 points. Typically you're given two x coordinates, say x equals a and x equals b, and then the secant line is just the line that goes through these 2 points, or the corresponding 2 points on the graph. And of course the point corresponding to x equals a would be, it would have an x coordinate of a and a y coordinate of f of a, and then for b it would be this. And so the slope of a secant line, I can just find the slope by, the normal way. I do rise over run, so I'd subtract the y coordinates and subtract the x coordinates like that. So that's the slope of the secant line. What's relatively new for this section is talking about tangent lines. So a tangent line, you're only given 1 point on the graph, and what the tangent line is, or what the slope of it is, it's the limit of the slope of a secant line as the 2 points get closer and closer together. So let me say that again, so maybe it's more understandable. Here's the slope of the secant line, and we put that here, and I do the limit as b goes to a, meaning, so like b is like the second point if you're talking about a secant line, and we're doing the limit as the second point goes to the first point. So that's what a tangent line is. Of course, I can rewrite this limit this way. You often see it this way. The only thing that's different is I changed all the letter b to the letter x. So that's the same thing. You can also see it written this way. This is like a substitution. If you substitute h is x minus a, you can get it in this form. And this is typically the easiest form to work with if you're calculating a derivative. So let's find a tangent line. And this isn't going to be a particularly easy one. I went straight to a function that has x cubed. X squared would be easier, but let's not be lazy, I guess. So let's find this tangent line. So part A is to do it at x equals 1. So I'm going to put in 1 for A here. So the limit as h goes to 0, f of 1 plus h minus f of 1 over h. That's the first thing I'm doing. So that's the limit as h goes to 0. Okay, so now I'm plugging it in here. 1 plus h cubed plus 2 times 1 plus h minus 1. And let me go ahead and put brackets around that whole thing. That whole thing is just f of 1 plus h. And then I'm going to subtract f of 1. So I'll put brackets around whatever that is. And then this is all going to be over h. So what's f of 1? I can just plug it in. 1 cubed plus 2 minus 1 would be 2. So that goes here. Okay, so this is now a limit that is a lot like limits that we've seen before. I'm going to expand this all the way out. A few things are going to cancel, and then I'm going to find that everything on the top has an h, and I can cancel all those h's off with this h. Okay, so that's what's going to happen. I just have to actually do it. So I have Pascal's triangle right here, so that's going to help me do 1 plus h cubed. So that's limit as h goes to 0, 1 plus 3h plus 3h squared plus h cubed. So that's just this, plus 2 plus 2h minus 1. Like that. And now, well, let me just, okay, I don't want to go too fast. I should see a bunch of stuff that cancels on the top. And in particular, what I'm expecting is I'm expecting to be able to cancel this h from the bottom, so anything that doesn't have an h should go away. So let me find all the things that don't have an h. This is 1 plus 2 minus 1 minus 2. They all go away. These four things add up to 0. Now, what else do I have? There's a 3h and a 2. So actually, I'll cross these things off now. Yeah, I was looking at my h's. There's a 3h and a 2h. So 5h, there should be some h squareds. So 3h squared, but I don't see any other h squareds. There's an h cubed. And that's it. That's everything. And sure enough, I can cancel an h off of everything. So this h is gone. This would now be h to the 1. This would now be h squared. And the limit as h goes to 0 of this would just be 5, because this is just 5 here, and h is going to 0, so 3h goes to 0, and h squared also goes to 0. So this is a line with a slope of 5. So this line should go through the point, let's see, the x value was 1, and the corresponding y coordinate is what you get from plugging in 1, and when we did that we got 2. And it has a slope of 5. So the equation of the line I can do, this is point slope form. So y minus 2 equals 5 times x minus 1. Right? Okay. So let's try part B. Part B is a little bit harder because we aren't given a specific number for x. It's just x equals a. So let's find the slope. It'll be, I'll do this the same way, except instead of 1s I have a's. So it's like that. I will plug it in, so that's a plus h cubed plus 2a plus h minus 1. Oops. Yeah, sorry, I'm going to have to fix this. I forgot to write limit as h goes to 0. So sorry, my writing is a little bit crowded, but this is the limit as h goes to 0 of, and this is just me plugging in a plus h, and then I'm supposed to subtract f of a. So what's f of a? That's a cubed plus 2a minus 1. This is all divided by h. Right? So now I have to simplify this like I did the last one. So how do I do a plus h cubed? I use Pascal's triangle again. So this is going to be a cubed plus 3a squared h plus 3a h squared plus h cubed. That's just that. That's just a plus h cubed. Now I have plus 2a plus 2h minus 1. And now I have this stuff. Let me go ahead and I'll distribute the negative sign here. So minus a cubed minus 2a plus 1 all over h. Okay, now let me use the same logic I used last time. I was canceling things, and I said I know one thing that definitely needs to happen, which is anything on the top that doesn't have an h should go. If it doesn't, then I've made a mistake. So there are some things that don't have an h, like this a cubed does not have any h on it. Luckily, I have this minus a cubed. This has an h on it, this has h, this has h. Okay, this doesn't have h, so something should cancel with this. And look, it does. Okay, this has an h, this doesn't have an h, so something should cancel it, and look, it does. Okay, so I'm happy with that. At this point, I can do the cancellation of this h, and I just remember I have to cancel a single h off of everything on top. So I get 3a squared plus 3ah plus h squared. That becomes this, and then plus 2, like that. And now finally that there's no h on the bottom, I can just plug in 0 for h. So when I put in 0 for h, this goes away and this goes away. I just get 3a squared plus 2. All right, good. So let's do another one involving a square root. So we're going to find a tangent line to this curve at x equals 4. So I find the slope the same way. It's going to be the limit as h goes to 0, and I'm using this again. Oops, I'm using this, and this time a is 4. So f of 4 plus h minus f of 4 over h. That's what I do. So what's f of 4 plus h? I do this. And then what's f of 4? F of 4 would be 1/2, right? And I put that all over h. I do the limit as h goes to 0. Okay, so we've done limits sort of like this before. The first thing that I see is I don't like fractions inside of fractions. So I'm going to multiply the top and the bottom by something that kills all the denominators. So I need to kill this 2, and I need to kill this 4 plus h inside the square root. So that's what I'm going to multiply on the top and bottom. And let me put parentheses here because I have to distribute this. So what happens? Yeah, so I just distribute this. When this goes here, the 4 plus h cancels underneath the square root, but the 2 doesn't cancel, so I just have a 2. When this goes here, the 2 cancels, but the other thing stays. So it's like this. On the bottom, I'm going to keep the bottom just 2 times h times square root 4 plus h, like that. Okay. So now what am I doing? Well, I like this a bit better in the sense that I don't have fractions inside of fractions anymore. However, I still have a problem. Just fundamentally, you need to keep working on these until you don't have h in the bottom, because h is always going to 0, and if you have an h in the bottom, that's always going to be a problem, because you're going to be dividing by 0 if you just plug it in. So we need to keep working on this. We need to do some algebra until we are able to cancel this h in the bottom. This is a familiar situation, though, because on the top I see square roots involved, and I see addition and subtraction. This is a situation where in the past what we've done is we've used the conjugate. I'm going to multiply the top and bottom by the conjugate of this. The conjugate, of course, would just be putting a plus here. So that's the next step. Let me multiply this out. What happens, you remember we're using the difference of two squares formula, so when I multiply this out, I'm going to get this squared minus this squared. Okay, so this squared would just be 4. This squared just takes off the square root, so I just get 4 plus h without a square root on it. Yeah? And on the bottom, I'm not going to multiply anything out. I'm just going to write 2h, 4 plus h, like that. Okay, now we should see that we're in much better shape. So these 4's cancel, and yeah, hopefully you can all follow this. I'll cross these off, and keep in mind what's left over is a minus h, right? Because this minus sign goes to the h. So at this point I have a minus h on top, and if you'll bear with me, because I don't want to write the whole thing again, I'm going to keep on canceling. Now that the only thing on top is this minus h, I can cancel this h on the bottom, which is great. Like that's my main goal of doing all this algebra, is just to cancel this h in the bottom. So if what I have on top is a minus h and I cancel it with this h, what would be left over is a minus 1. So, sorry, let me go over that one more time. The 4's canceled. At that point, there was only a minus h on the bottom, and then that h canceled this h, at which point there's only a minus 1 on top. So that's what just happened. And now that I've canceled the h in the bottom, that h in the bottom was the only thing stopping me from plugging in 0 for h. Because if I plugged in 0 for h, I would be dividing by 0. But now that that's gone, I can just plug in 0 for h. So what do I have? On the top, it's just negative 1, like we discussed. On the bottom, it is this, oops, so there's still this 2. This h is gone. This would now just be square root of 4, because I'm putting in 0 for h. And this would be 2 plus square root of 4. And then, yeah, of course, square root of 4 is 2, so here I've got 2 times 4, which is 16. Okay, so after all that, this is the slope of the tangent line, and I guess, so let's state the equation of the tangent line. So we found the slope. Whoops, there's a reason I'm not an English professor. I keep misspelling. I mean, I guess THRU is not even how you spell through in the first place, but I keep writing THRUE. Anyway, like I said, there's a reason I'm not an English professor. The tangent line goes through this point. It's x equals 4, and y equals like whatever the corresponding y coordinate is, and I guess we plugged it in before. We got 1/2, so that's the y coordinate that goes with x equals 4. So we have a line with this slope going through this point, so I can write y minus this y coordinate equals the slope times x minus this x coordinate. Yeah. And yeah, so maybe this video will be, well, we'll see how long it is. Because I just have one more example that I wanted to do out of this section. About velocity and position and this sort of physics stuff. So to give you a real quick rundown of this, displacement in physics is a word that we use to describe relative position, because of course there's no like objective position. There's only such a thing as relative position, as such as like I know how far away you are from where I'm standing, but that may be a different distance from where someone else is standing. And displacement can be positive or negative. Typically, we have a positive direction and a negative direction. If we're talking about vertical movement, up is typically considered the positive direction and down is the negative direction. So if I say I have a displacement of negative 5 feet from the ground, that means I'm 5 feet underneath the ground. Or if it's a displacement of positive 5 feet, then I'm 5 feet above the ground. But in any case, the velocity is just the it's the derivative of the displacement, where derivative is referring to one of these limits. It's like a slope of a tangent line. So as far as what you need to know to do a question like this, you're going to be given the displacement of a particle, and this is some formula in terms of t, and then you may be asked to find the velocity of that particle at a particular value of t. And the way you do that is you just use the same formula. It's the limit as h goes to 0 of it's just like this. It's just that this is your function. So we ought to be able to knock this out quick. I'm plugging it in. What's s of 2 plus h? I've got 2 times 2 plus h minus 2 plus h squared. And then what's s of 2? If I plug it in, I figure out that it's 0, actually, over h. We know what we need to do. We need to keep doing algebra until we're able to cancel this h from the bottom. So I've got 4 plus 2h minus, and let me put this in parentheses, because when I square this out, I'm going to get 4 plus 4h plus h squared, but I need to remember that this negative sign distributes through the whole thing. And then, I mean, I had brackets around this, but I don't really need brackets. The brackets weren't really doing anything. I was subtracting 0, which doesn't do anything. So I think I'm good like this. And then what happens? As usual, I expect everything without an h on it to go away. This 4 doesn't have an h on it, and it goes away. Now everything else has an h on it. Let me be careful though, there's some things to combine, like this 2h minus 4h is negative 2h. So it's like this. And now I can cancel an h off of everything. So this is now just a negative 2, and this h squared is now just h to the 1. And now I can do the limit as h goes to 0. This negative 2 is just negative 2. And this h is 0 because I'm plugging in 0 for h. So that's the velocity. Oops, can't see it. So that's the velocity, and let's try to be good scientists and put units on here. I'm usually not a very good scientist. I'm a mathematician, and once I go into the world of numbers, everything is just numbers. But if I'm making an effort to be a good scientist, I'll put units on things. The units should make sense in terms of the units we were given. If the position is in meters and the time is in seconds, the velocity should be in meters per second. So that's it. That's how you find the velocity, and it's nothing super special. In fact, it's using the same type of limit that we always use to find the slope of a tangent line, and we did several examples of that. So finding the velocity is not fundamentally different. Okay.